So if you want to talk about the ways that we can adjust a sinusoidal function, we have essentially four properties that we'll focus on, one of which you've already seen. The first is the period, and I'll explain what that 2 pi over b means in a second, where the period is essentially just the space it takes to repeat. So if we're thinking about the sine function in terms of like a unit circle, the period represents the amount of time it takes for the circle to complete a rotation. Sometimes you also hear this talked about in terms of something called frequency. Meanwhile, the amplitude is the height that the sine function, sine or cosine, reaches. Well, it's not quite just the height, it's more the difference between the middle and the top or bottom. So it's kind of like the radius. And if you picture that in terms of a circle, you can think of it as the radius of the circle that would be formed by that rotation. And then we have the two shifts, the vertical shift and the phase shift, which can be thought of as moving the circle to somewhere other than the origin, where the phase shift refers to a horizontal move to the left or right, and the vertical shift is, well, a vertical move up or down. And if we want to put this together, a general sine function can look a bit like this, where in our book we have a slightly different notation for how we put this together, but it means roughly the same thing. Where, to be clear, because it's not obvious looking at that picture, the value that we have a there corresponds to adjusting the amplitude. That is, it adjusts the height by making it stretch or shrink by a factor of absolute value of a. The value b corresponds to adjusting the period. So if you put a b on the inside and multiply it by x, you are adjusting the rate at which the function moves, where you are shrinking or stretching it by a factor of 1 over b. Because if you think about it, you multiply a b through, it would make it go through its root much faster, which would make the period, the amount of time it takes to get from one place to another, that is still the same in a sense, thinner. Meanwhile, the value c, a constant c inside of the sine function, is the phase shift, where if you add c, you're moving it to the right, which is why the book usually writes that as minus c, or excuse me, if you add c, it's moving to the left. The book puts in minus c, so that if you put minus c, you're moving to the right, because we want all things moving in the positive direction, but it's not that big of a deal. In any case, we have that for our phase shift, and then for our vertical shift, d added to the outside. That is what moves us up or down by d units. And if we want to handle this, I'm throwing a lot at you pretty quick. Really, we're going to see how you can handle this stuff with an example, but we got to get the steps here as well. What you want to do first is identify what happens to all of those properties. You want to look at the potential shifts. That is, you have to identify the values a, b, c, and d. Then for step 2, this is most of the work, you identify the 5 key points for the graph. These are your 3 x-intercepts, the maximum point and the minimum, where you can get this actually pretty easily using a thing called a quarter period, where what you do is you take the period that it's supposed to have and divide by 4 to find the values for x that you're going to be working with. It's a nice thing about the repetition of sinusoidal functions. Then, once you have your values for x, you turn those into y values for your key points by evaluating the function you got with those x values from step 2. And then finally, you make a curve through those points and graph a complete cycle for your function, where if you need a bigger picture than just one cycle, one period, you can keep going as needed. And next, we're going to see an example of this process.